So our keynote speaker is Johan Krebbers. He is VP IT Innovation and also GM Emerging Digital Technologies with Shell. He's going to cover Shell and cloud technology developments. So let's get straight on with our keynote. Johan, welcome. Are you there?
I am there. Good morning. I'm very pleased to be here. So maybe you can show the slides and off we go. Thank you very much. Good morning. So Johan Krebbers from out of the Netherlands, out of The Hague today. So we're going to talk about the following subjects. And let me first skip this slide. I won't ask you about this slide anymore. We're going to talk about these four. I first talk about how cloud has enabled all of this. Because if you talk about digital, there will be no digital without cloud. And then we're going to talk about the cloud and digital merger and how we in Shell we have made use of that combination and what kind of digital technology, digital deployments we have done in Shell. But let's first talk about the cloud element. We started in Shell with cloud about 7-8 years ago, and we signed our first contract with Amazon Web Services. Of course, it was a very different environment those days because it was very much an infrastructure-based service. And of course, over time, this has moved to very much making use of market services. So increasingly, in our case, we're looking for market service available on cloud, either on Amazon or on Azure or other environments, but really the market service is what it's all about. So we look at the capability less so than the cloud platform. Despite all of that, we do have a dual cloud platform strategy, both Azure and Amazon is being supported out there. But focus at market services, focus the move to software as a service. That's really what the future is. That's really what you should be looking at. And in that context, we're also looking at what does it all mean in the digital space. Without cloud, there will be no digital. And there's one other element which is also very important for the case of digital, which I didn't talk about so far, which is the open source. I always look at two developments in the market which are very important. One is the move to cloud. The other one is the move to open source. Both are important. Both have made to a lot of change in this market, and both are enabling the digital space out there. So cloud give flexibility. The cloud give fast access to new capabilities. Cloud give agility, but also open source will give you much faster access to new capabilities and more agile type environment. Agility is what it's all about. So agility, remind that word, is very, very important in this space. So if you look first at a typical digital workflow, it's important to understand that. And in principle, any digital activity you do always goes according to this workflow. On the left, you see very much where we collect our data. Yeah, you see very much where we have where you got your edge environment, you got your drones, you got your robotics, you got your satellite connections. All about collecting data at the refinery, at the production site, at a wind farm, at a solar farm, at a hydrogen plant, you name it. But the edge is where it's all happening. So the data is collected over there. It can be any type of data. It can be time series data, it can be event data, it can also be video, it can be sniffer data. So that any type of data is collected over there. In our case, that data always will go often directly to the cloud and not via an edge environment. We only use edge when it's really needed. So we only use edge when either it is time critical, we have to respond within so many microseconds, or the amount of data is too much to get to the cloud. But in 9 out of 10, the data will go directly from any edge environment around the world to a cloud environment in the center. And in our case, the cloud environment is a single global store where we bring together all our data, time series data, event data, alarm management data, you name it, any type of data out there is brought together into this single cloud environment in the middle. And we're going to talk about it later. Of course, that's why are we doing that? It's very much to support really our AI capabilities. So because we're really using that data to drive machine learning for predictive maintenance, machine vision to look at leakage detection or other errors, and NLP, natural language processing. So these are AI capabilities we use, and for that we need that data. And we need the data globally from the edge coming to the cloud, as I mentioned, alarm data, time series data, you name it. So out of that, with AI, we're creating information out of data. So now we have information. We now have something to do. We have now can make a decision with based on that information. Of course, you can make that information visible in many different ways. Again, you make it a set point maybe in your historian, or you say I'm going to bring it back to the operation another way, or I put into chatbots environment, or I use virtual reality. There are many different ways to really involve and really bring that SME up to date. But this is a typical workflow. Yeah, on the left you collect the data, and there's any type of data. You bring it normally to a cloud environment. In our case, a single Azure cloud environment. I'm going to talk about it later, where all the data comes together. And then we're using AI to get information out of that data. And once you have the information, you have different ways to take action. And the action can also be over time, and I'm going to talk about a lot of autonomous operations, that immediately goes back to the edge and say, make these changes over there. But here's the workflow. Remember, this workflow is important because we will come back to that in a number of cases. Let's talk about the edge first. In the edge, is really whatever the data is being collected, and you can use that by just fixed cameras, by drones. If you look at and on the next slide, you see an example of a drone. By a robot. On the right, you see an ATIX compliant robot driving around at our furnace refinery, making pictures, sniffing. Yeah, so collecting data, autonomous around the refinery. Their data is then moved to the cloud environment. And with that data, for instance, if you look at camera data of that robot out there, the user must see vision to say, okay, are there leakages out there? Is that valve is it open or closed? Is that meter, does it have the right values out there? It's really about that for surveillance purposes. Yeah, that's really what this robot is all about. But increasingly, we use a robot for maintenance. Yeah, we're using robots to do the clean the inside of a tank. We do a test with a robot with a drone to paint the outside of a tank. Yeah? And these are all new capabilities which are happening over a very short period of time. If you like using a drone to paint the outside of a tank was not possible until maybe 6-12 months ago. Yeah? These are very new developments, go very, very fast. So this whole space of maintenance robotics, a lot of things are happening. So don't really look at the space, and often we do it with startups. It's really the startup that comes to make the difference. It can be startups in the US, can be startups in Europe, like in maintenance robotics. Also in Europe, we got some very important startups in this place. It's all about working with startups, giving the opportunities, and coming to real solutions out there. The other one you see on the right is collecting drones, collecting data in our facilities in the US. But we bring all that data into a single cloud storage environment. We got about 8 million tags out there. So we're collecting data of about 8 million devices out there every so many seconds. All the data from across the world goes to one global store in Amsterdam. Why is that important? It's important for AI. And it's not just the time series data, it's not just the event data, but it's also alarm data. It's your video data, your camera data. It is any type of data you can think about. We collect at the edge, we bring to a single store, and a single store is used to train and exploit and develop our machine learning and machine vision capabilities. So it's all about AI. So that single store is important to bring the data together into a single environment. If you talk about data, it's also important that you think about the ownership of data. And what we try to do over here, shown on the left, you see the different ways where we're collecting data. Yeah, you see the different, I'll repeat the ways again. In all our cases, we bring that data into that Shell single store via 4G and increasingly 5G, but at the moment 4G, into that single store, all Shell owned. We want to own our own data, even if that data is collected by a third-party company with a drone provider, or a third-party company with their own other data collection capabilities. That data first will go to a Shell global store, and from there it will go to any of the stores that provider has out there, where you can apply their own algorithm. But we keep that data because we want to use that data for the development of other algorithms over time. So that data ownership, really think it through. Even if you get data collected by third-party companies out there, think about ownership. And in this case, we bring the own store and then make the data available to whoever needs it to drive the algorithm. Because we make use of a lot of market developments. And again, There's a lot of third-party smaller companies in this space, very active in the rapid development of these new algorithms out there. This example, we do our Pernis refinery in Rotterdam. On the left, you see that robot, that ATIS compliant robot, driving around, collecting video in this particular case, but can also collect, for instance, pictures of valves. Is the valves open or closed, or is there something else broken out there? Yeah, so that's collecting data on the left. Remember, collecting data. That goes automatically via our 4G network, for our public 4G network, to the cloud in Amsterdam. Cloud in Amsterdam, we have automatically applying machine vision or machine learning. If we machine learning, if we want to know predictive maintenance, if we want to know is this particular valve going to fail in the coming hours, in the coming weeks, or coming multiple weeks, then we better know about it, because then we can take measure before it actually fails. So machine learning is all about predictive maintenance. And also you have machine vision. If you want to say, okay, I see leakage out there, I see emissions out there. And that's why machine vision is very, very important. So once you have that information, you can then say, let's say in the case of the valve, I send an operator over there with his RealWear headset, he has all the information with him to start repairing or fixing that environment. If something is broken, I use 3D printing capabilities. Yeah? So lots of things are happening out of the AI capability, because then you have then the information you need to make your next step. It's all about improving the availability of your facilities. Yeah, it's removing, taking out unplanned downtime, shortening your turnaround, etc. It is an example of what we do in our Rotterdam facilities. So these are just further examples we do with drones and robots around the world. So these are facilities which are being used globally around our wind farms, solar farm, hydrogen plants, you name it. They are really used around the world. You see it over here in these 4 pictures. On the left, we use the facilities in our upstream and integrated gas and manufacturing facilities, our refineries, our chemical plants, our production sites around the world, whether it's in Europe, in the US, or in Asia. We are using those facilities at a global level. In our increased number of solar farms around the world, in our increased number of many offshore wind farms around the world, and of course, in our hydrogen plants we have around the world as well as the hydrogen stations we're creating around the world. So these are facilities which are being used in Shell across each of our asset types. They're not unique to one, they're unique to all of them, but we use them in all of them. We talked about a moment ago about 3D printing. Yeah. 3D printing becomes more and more important. Why? Because it can take stock out. Instead of having lots of stock out there of spare parts, which only might have to use maybe one every 2 or 3 years or 4 years, but I still need them because when they break, I need them. I can't wait for half a year to get the spare part coming out. Yeah? So the 3D printing of metal becomes increasingly important. And why is it important as well? Because often you got very old parts out there. If a refinery can be 30 years old, so you might have parts breaking after 30 years. 3D printing is ideally to scan such a device and recreate it. Yeah? And again, we do that with multiple partners around the world, and also really creating our own digital warehouse. Instead of having a physical warehouse, you have a digital warehouse where you kept the digital images of your various parts out there. These are just some examples of around the world. It's also important you print these devices, these spare parts, close to the facility. So if you have a problem in Singapore, we print a facility in Singapore. There's no need for CO2 emissions from flying around the world with spare parts. You print close to the facility you need it. It's another big advantage of the whole 3D printing, in addition to much shorter lead times, of course, and of a cost advantage. Something you've heard about many times before is blockchain. I mean, you've heard about blockchain maybe for the last 5-6 years. It never really materialized. And we talked about it, and people often got confused when we talk about blockchain with Bitcoin, but we talked about it a lot, but it didn't really materialize. Obviously happening now over the last 6 to 9 months, several examples where it does materialize, like in the energy space, proof of origin, proof that this particular aviation or this particular fuel or this particular hydrogen is really green. Yeah, so this proof of origin becomes an important component where blockchain will play an important role. So be aware of that one. The other one is the trust devices, making sure that the device is really what it says. And we have an example over here in Shell called the Falcon project, where we create a so-called digital passport of a device. What is it in the digital passport? It says when it was manufactured, so who manufactured it, when it was manufactured, what that passport was created. Yeah. Then when it's being inspected, when it's being installed. So the whole history of that device is stored in a secure manner in a blockchain environment, in a blockchain blockchain center. Yeah, and why is it important here? Because normally you have to keep you have lots of paperwork to keep track of that material. Because you have to prove when was the device inspected, when was it maintained. In the case of blockchain, you keep that as part of this trusted device. You keep all that information into a single blockchain charter, and really any party has access to that. But any party can only add to that. Nobody can change the information. Once information in blockchain, it is there for the rest of the life. Nobody can tamper with that information. So everybody can trust the information in blockchain. Whether you're an inspection party, whether you're a maintenance party, whether you're operator, all the information is in one environment. Yeah, and that's really what blockchain can bring to the table. You create yourself what I call a trusted device, where all information is well known, it cannot be tampered with. And this example, we have a project running with Falcon in Qatar. You see the parties involved, they're all involved, have access to that single charter out there, and really can maintain and update the data as they see fit. Another one about the whole blockchain, not the blockchain environment, about the whole end-to-end digital environment is the move to automate operations. How can I further automate my operations? Again, it's all about data collection on the left, sensor data, lots of data, bring it to a cloud environment, apply machine vision, apply machine learning, and then make decisions out there. So it might not go to a human being, but the machine vision might be good enough to say, I know what the problem is, I know what to do about it, and I will do it. So these are steps, but over time, over a number of years, you move to autonomous operations. You also see the term digital twin. We'll talk about digital twin in a moment. Another example is around global collaboration. Yeah, it's so important that you share learnings in digital world. Yeah, and there are new technologies like virtual reality, augmented reality are important players out there. I've shown a number of examples of how they can globally help you, especially in this world of Corona, work in a different way. This is a big example. Became very popular over the last 6 months. Instead of people flying for inspections to check something at the yard in Seoul, or something at the terminal in South Africa, or something somewhere else in the Netherlands, people used to fly out there, go out there. None of that is happening anymore, of course, since Corona. And we now are using these realware headsets where the operator remote side is wearing that headset, and anybody around the world has full access to what the person is seeing. It's two-way traffic, there's audio and video, and you have full control at the remote side what's happening out there, and you can also give clear guidance to the operator. You give remote support, what to do, what not to do. You can give clear instructions because you also has a small display in front of you. Very important, and the use of this exploded over the last 6 to 12 months. And in principle, what it means, I can do anything from home. Whatever happens in the world, anywhere, I can see it from my home environment. And you see a number of examples over here, but the bottom line is, I don't need to be there. I can be anywhere in the world, sitting at home in this particular case, and I have full control, full sight, what happens anywhere in the world out there. Digital twin. You've heard about the term many, many times. It's a much overhyped term. It becomes vitally important for your assets because it gives you a single view of your operational data and your engineering data. So it's really that single view which you never had before. So when you start really rolling out the digital twin and create a single view, bring the data source together, align all these data sources, yeah, you go to a very different way of operating than you do today. It will amazingly different how things will happen once you have created that single view used in digital twin environment. So all these technologies we're talking about, all the digital technologies are deployed across Shell. When you go to your retail station, where we're using AI to calculate or prepare the next offer for you. When you go to a charging environment, where we're using AI to optimize the power creation. Yeah. So it is wherever you touch Shell, we are using these type of technologies, not just in the asset, but anywhere across our enterprise. These are two things which are also important. These are two industry developments. On the left, the open footprint. We are working with 25 other companies to create a standard way of storing our carbon emissions, G emissions, so greenhouse gas emissions, so carbon, CO2, etc. On the right, OSDU. That is with 170 companies out there. We have created an open data platform standard for all energy sources, for oil and gas, but also for wind farms, solar farms, etc. Both go to the Open Group home site and you find information about it. All this is underpinned because all this digital does expose from a security point of view. And because you work in a cloud environment, in a public cloud environment. Therefore, cyber defense, information security remains vitally important in this world, because we more and more go to that public world out there. We are not behind our own on-premise environment anymore, in a public cloud environment. And let me stop over here. So thank you very much for listening. I hope this was useful. I hand over back to the presenter.
Okay, Johan, that was an inspiring presentation, actually, and it's really brilliant to see so much progress. Having done a lot of these events in the past, I think this is one of the first times I've really felt like this isn't about what we're going to do in the future, but we're absolutely doing it now. So thank you so much for sharing so many real case studies. So just a reminder to everybody listening in, this is Future Oil and Gas 2020, and welcome. And we do want, of course, to get as many Q&A questions from you as we can throughout the 2 days for all of our speakers, and that includes here Johan as well. So Johan, while we wait to see whether we get any more questions coming in, I have several for you. And I think the first one is, you talked about robotics and how it's really starting to be used, and how the key to robotics is to be working with startup companies. You're looking for more. Can you just talk a bit about why startup companies? Why is that so important in the world of robotics? And are there certain areas right now where you're looking for more partners?
Well, first, startup is important in the whole world of digital, because a startup company often bring the new capabilities to that market always. Yeah? So for the whole world of digital, a startup company is vitally important. In the case of robotics, it's even more so. And because if you look at what we do in the case of robotics, when we show that yellow robot in Pernis, it's from a Dutch Delft startup company, X Robotics. Why with startup company? Because they really bring the innovation to the space. Because in this case, it needs to be an ATIX compliant robot, which is quite hard to do. To make something ATIX compliant, so you can run it in an explosive environment like a refinery. So it's very important, in those type of environments. And also the agility, the ideas of how you can do things in a very different way. Then we saw it with that. We also see it with we work with a Swiss company together, a drones company, to paint the outsides of a tank. The large tanks, you remember outside. Today you need scaffolding to really paint them. Well, we now do a test with a Swiss company who use drones to fly around and really does both the removing of the old layers, the cleaning up, the painting and the validation as with a drone. Yeah. But again, small company, because they have their bright ideas, they are very focused at that one idea. Because you need to work with them also. Because you also have to work differently with a small company than with a large company. But also make sure, because they have much different timelines than, of course, you often might have. Also, that is important that you acknowledge that, of course.
So if companies do have innovation that they think would be relevant to you, how do they just contact you directly, or how do they contact you directly?
Give you my email address, and we'll talk, because we really do a lot of that work in the digital space. Yeah.
Okay, super. Again, I was just very impressed with the whole presentation. I think one of the things you dealt with, which we all know is a problem with digital in the energy space is the ability to scale up. So often you'll have success in one asset or with one project manager. Others kind of aren't aware of it or don't want to use it, don't want to take the risk or whatever. You talk about Shell now. A lot of these innovations are happening globally, not just in one, not just kind of in one local environment. How have you achieved that sharing culture? Because it's kind of a behavior and culture problem, right? How have you done that within Shell?
Well, that was really part of our digital agenda. When we started really heavy with digital in Shell, maybe about three to 4 years ago, it started first bottom up, but very soon became top down, from the board down. And we had sponsors at the EVP level across the businesses to help us drive that agenda top down, because digital will not work without top down support. If you don't do that, it becomes very patchy. So the top down support is very important. And of course, you always will test something in one asset. And of course, then share that information from the one asset. That's where the top-down support always is very important. So making sure you have a top-down digital, called people infrastructure, governance infrastructure, which will help you to deploy from one asset to another asset. So that top-down people have an accountability at the EVP level, VP level, is vitally important.
Have you set up some kind of a sharing system or incentive as well then, or is it just a top-down mandate?
Well, it's two things, a couple of things. First, we created already 3 years ago a digital center of excellence. So there's a group of people sitting in the business, developing these new capabilities. I'm a member of that, developing these new capabilities. Sit in the business, not in IT. We closely work with IT, of course, from a deployment point of view, because you need IT to deploy, but you do with the business, and a link to the business is vitally important. So you need to have a link with the business, but also need to have a capability, and the capability to be close to the assets. So don't make this a very theoretical exercise, but also if you do something, how quickly can you show to make this operational, so you can scale up around the world? Because it's nice to show a proof of concept, but a proof of concept does nothing to the company. Only when it becomes an operational capability anybody can use, it has impact. Otherwise, you're wasting a lot of money.
Impact. Of course, I think that if you talk about the big scale of impact, the energy industry somehow famously has been so slow in really innovating and encouraging disruption from digital. Fantastic presentation, which I think showed that it's now starting to happen. Is digital the key to a step change in competitiveness of oil and gas? Particularly given the fact that with energy transition coming, so CCUS and hydrogen is two examples of key technologies that the oil industry has, I guess you could say, a birthright to own and take forward, but only if it can quickly become economical and competitive. Is digital the answer to that?
Well, digital is the answer, but of course, with digital, things like data. Yeah, I mean, digital is the term, but this is underpinned by data. Why? Because if you look at my presentation, I always started with data, and data. And the exploitation of their data is all about how you exploit that data with machine vision, with machine learning. So digital is really, I take all the data I can get, I exploit the data, I make use of the data in my existing businesses, efficient, but also for creating new businesses. So yes, it is digital, but with digital is really the thing behind it, data and all the elements behind it. So that whole work I showed, collecting data, bring it to the cloud, make information out of it, and then do something with that information. That applies to hydrogen, solar, wind farm, you name it, anything you do.
I think that's a great kind of closing quote. To be successful in digital, it's actually data, data, data. So, Johan, I have so many questions, but we are out of time. This is an absolutely packed agenda, and we are going to try and stay on time. So, on behalf of all the organizers, thank you so much for opening up the conference today and sharing some of the real case studies, which I think is just brilliant to see that this is moving now to real case studies and success. So, thank you to you.
Thank you. I'm a pleasure to be here, of course. Thank you very much, Sam.